Hi, this is Pankaj Kumar Pandit, and from this video, we are going to start graph series. In graph series, as you can see, I have included quite a decent number of questions, and I have segregated these questions into a subtopic like DFS, BFS, topological sort, union, find, advanced graph. In advanced graph, we have included digital algorithm and much more. So I think these much of problems are enough to crack any type of graph question. So today's video, it's focused about the graph representation. So it's a very important topic. Before you go through other algorithm, DFS and BFS, you have to learn how to represent a graph. So what are the various ways to represent a graph? So before moving to learn various representation of a graph, let's just uh, see what are the different types of graph, like how undirected and directed graph. I'm talking about undirected and directed graph. So I will search it and then we will see what is it. So this is undirected and directed graph. As you can see, what is the difference between undirected? Undirected are the fundamental concept theory. So as you can see, directed graph has an arrow and undirected graph doesn't have an arrow. So if I would say, let me go through. Okay, so let's say I have the one node, two, and three. So this is undirected graph. Undirected. Okay, spelling are not correct. Don't worry about it. Okay, this is undirected graph. I can also represent this as okay. This is node, and one arrow is here, one another arrow is here. So this is two, and this is 3. So I can represent this undirected graph as a directed graph. So there is two edge, like one edge is going from 1 to 2 and another edge is going from 2 to 1. So this is directed graph. It's also says undirected graph. Don't confuse between, like, undirected graph is represent like one single line and the directed graph has use one arrow. This is two arrow are using, so uh, combining this will become like one arrow. So don't confuse yourself. Okay, so there are two types of graph, undirected and directed graph. Now let's move to the what are the various way to represent a graph. Okay, so let's just search what it says. What are the different uh, different ways to represent the graphs? Okay, so GFG again. Okay, so representation of graph. Here are two most common ways to represent a graph for simplicity. Okay, so unweighted graph or unweighted. So don't worry about this unweighted graph or weighted graph. We will uh, cover this while we are facing the problems. Uh, when the problem comes with weighted or unweighted graphs, we will see it that time. Okay. Now don't worry about now adjacency matrix and adjacency list. Uh, Adjacency list is the most important. Like most of the time we are using adjacency list. Adjacency matrix is just learn it. Nothing to think that much. Like I'm going to start with adjacency matrix. So let's just quickly cover this. So let's start. So let's take an graph. So I have a graph like 2, this is 4, this is 6. Okay, let's take not 4 and 6 and like this. We will just continue the things. 1, 2, 3, and this is 4, and this is 5. Okay, whatever number of nodes we have, like in this case 1, 2, 3, 4, 5, 5 nodes we have. So we will create 5 cross 5. So we are learning what we are learning, adjacency matrix representation of graph. So whatever the number of nodes we have, we will just create a 5, that number of let's say n number of nodes are there, so we will create n into n. Okay, so since matrix number start with 0 1 2 3 4, and as you can see there is a 5, so what we have to do is like we have to create n plus 1 cross n plus 1 matrix to represent 1 2 3 4 5, since there is no 0 as a node. Okay, so let's just create 6 cross 6 matrix in this graph. So how it looks like 0 1 2 3 4 and 5. Okay, 0 1 2 3 4 and 5. Okay, I'm sorry for the diagram, I'm not good enough. Let's just, okay, okay, this is the fourth. If you anytime feel like it's going slow, so you can just 2x the speed. Okay, I have created 6 into 6 matrix. Now I will put uh, 0 or 1 into the cell. 1 represents there is an edge, 0 represents there is no edge. So let's take this one, 1 and 2. There is an edge between 1 and 2. Okay, so how we will represent? There is an edge between 1 and 2. So this is the 1 and this is the 2. If you take this like where it is crossing to each other like this, so we will mark it as a 1. 1 represents there is an edge, so we will just make it simpler. So here it is 1. Now since it is undirected graph, that means if there is an edge between 1 to 2, like from 1 to 2, so there is also an edge between not between from 2 to 1, so it will be 2 to 1. This is 2 and this is 1, so 2 to 1 there is an edge, so 1 is the represents the edge. We will do the same thing for all the edges. So this is the edge and this is edge 1 and 3. That means from 1, this is the 1, and 3 there is an edge, and also 3 to 1 is edge. Now we will do the same thing for a 3 to 4. Let me erase this. Now we are here 3 to 4. This is the 3, this is 3, and this is 4. There is an edge. Now 4 to 3 is also edge. So this is 4 and this is 3. Here it is edge. Now only one edge is left. Let me erase this, and this is the edge 1 to 5 and 5 to 1. This is 1 to 5, 1 to 5 there is an edge, and 5 to 1 there is an edge. So rest of the cell is going to be 0. 0 represents there is no edge. Okay, so this is how we represent a graph in a adjacency matrix. So there is also implemented, like if I explain this, like we will create a matrix of size whatever the number of nodes we have, like they represented as v represents vertex, so number of vertex is going to be that size of the matrix. Okay, here we add a node, add a edge. Now add edge one by one, so there is an edge between 0 to 1. Since it is undirected graph, so we will mark it as a I to j or j to I as a 1. I hope this makes sense. Now, this is the most important adjacency list representation. We are going to use this very frequently. So you have to understand carefully. Now let's take this as a graph. So we have, okay, so 0, 1 and 2. Okay, this is a graph. So uh, we will also create a matrix, like we are going to use vector of vector, adjacency list. We will call it as a dj. Okay, we will give a size. Or what is the size? We will give size as a vertex or number of nodes we have. Like it is starting from a 0, so we will just provide n. If it is starting from a 1, then we will provide n plus 1. Okay, now we have n equal to 3. So this is the list: 0, 1, 2. Okay, now since it is a 2D, we are using vector of vector, that means 2D, and we haven't provided the inner size, like uh, uh, how many number of columns we have. We didn't provide. We provide only how many number of rows we have. Like this is the row 0, 1, 2. We didn't provide how many number of rows we have. Okay, now we will go to every edge. Remember, every edge, like 0 to 1, there is an edge. So what we will do, like 0 to 1, there is an edge. 0 to 1, so 0 to 1, we will push 1 at the index of 0. So there is an edge from 0 to 1. Since it is undirected, we will also going to put 0 to 1. Like there is an edge from 1 to 0. Okay. Now let's take another edge, which is this 0 to 2. Now it says there is an edge from 0 to 2. 0 to 2. So we will push 2 where at the row 0. Okay, now since it is undirected graph, there is also an edge from 2 to 0. So 2 to 0. Now let's take another edge. Another edge will be 2 to 1 or 1 to 2. There is an edge from 2 to 1. This is 2 to 1 or 1 to 2. This is 1, 1 to 2. So this is the graph. This is the adjacency graph. Uh, First time, to me it's not understandable, but through the practice I have learned. Like I have used pen and paper. Like I have created several graphs. Like you can let's do one more example. I think then I hope at that time uh, that makes sense. So let's take 0, 2, this is 1, and this is 3, and this is 6. Not 6, what I'm doing. This is 4. Now there is how many number of nodes we have? N equal to 1, 2, 3, 4, 5. 5 nodes we have, so we will create 5 adjacencies. So it will be vector of vector integer, and we will call it adjacency list adj, and we are just providing number of rows. How many number of rows we have? 5. So this is the index. 0, 1, 2, 3 and 4. This is index, or you can treat as a node. That's it. Index equal to nodes, you can say. Okay, now go to each and every edge. Okay, this edge. There is an edge from 0 to 2. From 0 to 2. Put 2 at the index of in the index of 0. And since it is undirected graph, there is also an edge from 2 to 0. 2 to 0. Let me separate this so that okay. This is this thing is an index. This thing is index, or you can treat as a node. Okay. Now let's move to the next edge. The next edge is this 0 to 1. There is an edge from 0 to 1. From 0 to 1, put 1. Since it is undirected graph, there is an edge from 1 to 0. 1 to 0. Now let's go to the next one, 1 to 4. There is an edge from 1 to 4. This is 1 to 4. There is an edge 4 to 1. This is undirected graph, so 4 to 1. Okay, the last edge we have is 0 to 3. So this is 0 to 3. 0 to 3. There is an edge from 0 to 3. So we will push 3 to 0. So 3 to 0. This is the graph representation. So we generally we have a given like in the vector form. Since vector of vector, uh, we have a given edge, so we have to create a graph from that edge. Like uh, this is an edge. Like there is an edge between 2 to 0 or 0 to 2. Since it is undirected graph, so there is an edge between 0 to 1 or 1 to 0. Since it is undirected graph, and 0 to 3, 0 to 3. One more is 1 to 4, 1 to 4. So in this way we have a we generally we have a given in question like this is the edge and this is undirected. So from this given thing we have to create this graph, as simple as that. Let's see what it GFG says. Simple. We will just we just create a vector of vector, and we will just provide the number of nodes we have, or you can use as an index, number of index we are providing, and we will just call the function add edge to the adjacency list 0 to 1. Since it is undirected graph, there is an edge from 0 to 1 or 1 to 0. So let's see what the function to add edge. We will be providing adjacency list I and j. I and j, what it says? I says the node and j is also node. So we will push adjacency list. One second. This is I to j. This represents there is an edge from I to j, and this the second one is represent like there is an edge from j to I. So this is undirected graph. Okay. After that we will just display the things. It's easier. Okay. So this is what we uh, use to represent the graph. So in the next from the next video we will start the DFS, and I think that's enough to learn the graph representation. I would suggest you, I would recommend you use pen and paper, or you can use any code editor, VS Code. Just try to implement this. If you don't able to do it yourself, please take this and write uh, on your editor, on your yourself, and practice more, make a graph, and create a adjacency list. That's it. From the next video, we are just going to start DFS and BFS, and then I hope this video will be good enough to start with the graph. Thank you.